Assalamualaikum and good day. So, let's look at a new subtopic which is limit and continuity of trigonometric functions. Okay, the first one, as you can see, these are the graph of the trigonometric functions, the basic one. The graph of y equal to sine x, as you can see, it is continuous everywhere because it doesn't stop. Okay. And then the graph of y equal to cos x is just the same, it's continuous everywhere. It oscillates from negative infinity to infinity. Okay, it oscillates all the times and there is no break. Okay, and for the graph of y equal to tangent x, as you can see here, there is actually a break. For example, here is negative pi over 2, and here is at pi over 2. 3 pi over 2. This is because at this point, at the point of 90 degrees, and it's the same angle. Okay, that means the value of tangent 90 is infinity. So there is an asymptote at every value of increasing of 90 degree there. Okay, the repetitive of 180 degree from pi over 2 and then to 3 pi over 2 here. There is asymptote there. Okay, this is asymptote actually. Line which we cannot touch because it will goes towards infinity. Okay, it's either positive infinity or negative infinity there. Okay, so as you can see here, the conclusion that we can make is the graph of sine x and cos x are drawn as continuous curves, but not the graph of tangent x. That means tangent x is not continuous everywhere, but sin x and cos x here are continuous everywhere. Okay, let's look at an example here. You need to determine whether the function f(x) equal to sin x is continuous at x equal to pi over 2. Okay, there are three conditions to check for continuity. So the first condition is f pi over 2. That means we need to calculate for the value at that point whether it's defined or not. F pi over 2 is equal to sin pi over 2, which is equal to 1. And then the next one is check whether the limit exists or not. So here limit sin x when x approaches pi over 2 from left is equal to 1, and so does from right is equal to 1. And since the values are the same, therefore limit fx when x approaches pi over 2 is equal to 1. Okay, next is check for the third condition, whether f pi over 2 is equal to limit fx when x approaches pi over 2. And here, as you can see, the value here is 1, and here is also 1. 1 is equal to 1, that means equal value. Therefore, we can conclude that fx is continuous at x equal to pi over 2. Okay, and here is a theorem. Okay, let's say if c is any number in the natural domain of the stated trigonometric function, then we have limit sin x when x approaches c is sin c. The same goes for other trigonometric functions. That means we substitute the value of c in x. Okay, and then here the limit symbol can be moved through a function sign if the function is continuous. Okay, remember, if it's continuous, so the limit sign can be moved in front in and outside of the trigonometry. Okay, for example, here we have limit cos gx when x approaches 1. Since cos is a continuous function, so here cos, we can actually rewrite it as cos, and open the bracket, limit gx when x approaches 1. Okay, it doesn't matter, 1 is just a value that we wrote here. It can be c, a, negative 4, and such. Okay, and others. Next will be, let's say this is an example. We need to find the limit cos x squared plus x minus 6 over x minus 2 when x approaches 2. And as you can see here, when we substitute the value of 2 in x, we obtain limit cos, here should be no limit. Okay, we obtain cos 0 over 0, which is still indeterminate form. Remember, 0 over 0 is not equal to 1 or infinity. Okay, it is in indeterminate form. So right now we need to factorize to cancel the common factor. Remember, if it is in indeterminate form, the first thing that you need to check is to cancel the common factor. And if the form involves radicals, we need to multiply with the conjugate. Okay, here we factorize the numerator with x minus 2x plus 3, and the denominator remain as x minus 2, and we can cancel out the common factor here, x minus 2, and thus we have limit cos x plus 3 when x approaches 2. Substitute the value of 2 here in x, and we have this is equal to cos 5. In order to obtain this value, you need to make sure that your calculator is in mode of radian. Okay, in the radian mode. Okay, next example would be this one. Find the limit sin 1 over 5x when x approaches positive infinity. And therefore, we just need to substitute x equal to positive infinity in x. Okay, here is sin in bracket 1 over 5 times positive infinity. Anything times at infinity gonna be infinity again. 1 over infinity is equal to 0. And hence we have here sin 0, which is equal to 0. Okay, that's it for the part 1. I'll continue in the second part. Thank you.